So for the first couple of pages, you really just have to know your basic area formulas for your shapes. And so if you haven't already gotten this down somewhere, you want to make sure you have a list of these to study so that you know all of your basic shapes and their area formulas. Just as a review, for your circle, you are going to make sure you know the radius. Now, this is not the same as a circumference where you can have either. For a circle, for area, you must know the radius. And the formula for the area of a circle is going to be pi r squared. For the triangle, you need to know the base and the height. And so for this one, you want to make sure you have your perpendicular height and your base. And for the triangle, you're going to have 1/2 base times height. For a parallelogram, we have the regular parallelogram, which just includes your base times height. And this will work for all parallelograms, but we also had a special one for our rhombus. And with a rhombus, you can use either the base times the height, or if you know the diagonals, you can use the two different diagonals as well to calculate your area of your rhombus. And so for that one, you would say 1/2 diameter 1 times diameter 2. Now the trapezoid kind of combines the formulas of the triangle and the rectangle because you have two different triangles and two different bases. And so you have base 1 and base 2. And you also have to consider the perpendicular height for this one as well, like you do for both triangles and parallelograms. And so the formula for your trapezoid then is going to be 1/2 your height, base 1 plus base 2. And then the last one we looked at is your regular polygon. And for this we introduced a new term, which is the apothem. And the apothem goes from the center of your polygon perpendicular to a side. And so you have your side lengths, of course, which make up your perimeter. And so for a regular polygon, it is going to be 1/2 your perimeter times your apothem. And remember, these are the ones where if you don't know your apothem or you don't know one of your side lengths, you may have to use either right angle trigonometry or special right angles to calculate those. So the first page is basically just doing those formulas. In fact, for this one, I just gave you everything except your regular polygons in the first 2 pages. And the first page wants you to calculate the area. So like number 4 is a triangle. They gave us our perpendicular height. So we're just going to say 1/2 base times height there. And when you multiply that out, you'll get 1/2 times 10 times 8, which will give you 40 square inches. And so that would be your answer for number 4. The difference between the first page and the second page is that on the second page, they have given you some of the information and they want you to back into the information that you don't have. And so this is a trapezoid. So we are going to use our 1/2 height, which they gave us, times base 1, which they gave us, and then base 2 we don't have, so we'll just put a variable there. But what they did give us is they gave us what the area actually equals, so 12.2. And so at this point, you're just doing basic algebra to solve. You're going to multiply the 1/2 and the 3.2, which is going to give you 1.6 times the 6 plus x. And you do not have to distribute here. You can actually go right to the division, 1.6 on both sides. So you have 6 plus x equals 7.625. And then, of course, you will just subtract your 6 from both sides. And you will get x equals, and they want you to round to the nearest tenth. So you're going to get 1.6 here as your answer. For the last page, I pulled out 2 different ones to show you. The first couple really give you all the information that you need. If you'll remember, like we talked about at the beginning, your formula is 1/2 perimeter times apothem for the area of a regular polygon. And in this case, they really gave you everything you need. They gave you your apothem, 20.4, and then they gave you a side length. Now, I will tell you the number one mistake here is that instead of putting in perimeter, people plug in that side length. Don't forget, when you have side length, you have to multiply by how many sides you have. So in this case, we have 7 sides. And so when we are calculating the area here for this particular one, we are going to say 1/2, and our perimeter is going to be 7 times 19.6. All right. And then we will multiply by our apothem, which is 20.4. And so for this one, perimeter is sides times the number that you have, number of sides times the side length, and apothem they've given to you. And so there's not a lot of calculating other than just putting it in. And you will get rounded to the nearest tenth, 989.6. So these are very simple, and you don't have to do any right angle trigonometry for it if they give you the side length and they give you the apothem. What you'll notice is it gets more difficult after that, as they haven't given you everything that you need. And so you just have to figure out what you need, what you have and what you need. So if you look at this next one, we have 13 squared to 3 over 2, and I picked a little more difficult one. And we can see that they have given us that measure for the apothem specifically. And so if they show you the apothem and a measure, then that is the measurement for the apothem. It is not a measurement for a side. That would be on the outside, like it is shown up here in number 17. And so they've given us the apothem, but we need the perimeter. And so in order to find the perimeter, we will have to calculate it using either special right triangles or SOHCAHTOA, right angle trigonometry. And so you want to create that triangle in here so that you can see what you're looking for. And so if I create this triangle, then I can tell that I am looking for this angle so that I can find this side here. And that way I'll be able to double that and get my side length of my polygon. So remember, the first thing to do to calculate the angle up here is we are going to take 360 divided by the number of sides that we have, and in this case it is 6 sides, which will give us 60, and then we divide that by 2 because we have cut it in half right here, and that will give us 30 degrees. All right, so this angle measure right here is 30. And so if we pull that triangle out, you can see that I have the long side of a 30, 60, 90 triangle, and I need the short side. And so there's 2 ways to do this. If you want to do right angle trigonometry, then to get from the long side to the short side, you are simply going to divide by the square root of 3. And so if I have this 13 square root of 3 divided by 2, and I divide that by the square root of 3, then you can easily see that those cancel. And so the side length that I'm looking for down here is going to be 13 over 2. All right. If you're not comfortable with that, you can use SOHCAHTOA, and you have an opposite side that you're looking for and an adjacent side that you have. And so you would say that the tangent then of 30 should equal the side you're looking for over this right here. And if you multiply, you should get basically the same thing. Now remember, this is only half of our side length. So I am looking for the entire side length here. So I need to multiply this by 2, which is going to give me 13. And so now I have everything that I need. I have exactly what they gave me up here in 17. I have my side length and I have my apothem. And so I am simply going to plug those into my formula to get my area. And so the area is going to be 1/2. I have 6 sides times my side length, that is my perimeter, and then times my apothem. And it is rounding to the nearest tenth, which means you need to plug it in and calculate that rounded. And when you plug all of that in and round it to the nearest tenth, you are going to get 439.1. Now, if you used the tangent method, just really quickly, your short side of your special right triangle, so your short side here is going to be the tangent of 30 times this crazy fraction here. And remember, you do have to double it. So multiply by 2 before you plug it in for your side length. And you should get the same thing. You should get 13 if you do it by the tangent method or by the special right triangle method. But either way, you're going to get 13, and you will get 439.1 when you plug it in.